You're listening to Within Tolerance, a podcast for machinists by a machinist. I'm your host, Dylan Jackson of Proteum Machining, and this week I'm joined by Aaron Gough of Gough Custom Knives. Welcome, Aaron.
Thank you. Thank you for having me, Dylan.
Yeah, thanks for taking the time.
Yeah, of course, man. It's, you know me, I love talking about manufacturing, and I'm a nerd like you, so it's a good thing to be on.
Yeah, definitely. So if people haven't seen your knives or seen your company, what does Gough Custom Knives do?
I make knives. that much is obvious. And I make knives in a bit of an unusual way compared to most knife makers in that I use, as much CNC as I can. I really love automation and I love manufacturing processes. So I try to, optimize things as much as I can. And I make one model of knife, which is called the Resolute. And it's a kind of jack of all trades outdoors knife, so hunting, camping, that kind of thing. And I have a bit of a different philosophy than a lot of knife companies, a lot of knife makers, which is that I have one model and I've refined it over the course of many years, both in terms of how it's made and how it performs, how it functions. I don't want to be in the fashion industry,
Right, and you're on the Mark III of the Resolute?
Yeah, that's correct. So the first two versions happened relatively quickly, and then the third version has very much stood the test of time. Like there's been small changes along the way, but it's relatively unchanged for the last couple of years.
All right. Well, I definitely have some questions on it, but before we get into that, how did you get to that point? How did you get to fall in love with manufacturing and get to the point where you wanted to be making knives on CNCs?
It was definitely not a deliberate thing. That's kind of the funniest part, I think. So when I was younger, I grew up in the country in Australia, always had like a Swiss Army knife or something on me. And, I used to go to like garage sales and antique stores with my parents, and I would buy like, nice old vintage cutlery and then take it home. I'm like, 12 years old at this point, and like, chuck it on the bench grinder and like, make myself a little outdoors knife. They're basically making shivs. They weren't really very good. And after a couple of years of mucking around with that, I ended up getting in touch with the Australian Knife Makers Guild and being like, oh, can you, is there someone that could help teach me? And so a lovely dude named Neil Charity, he was actually like a grumpy old machinist type. I spent 2 years with him. Just like once a week, I'd go down to his house and he would, show me the ropes and help me out. But I was really too young to absorb a lot of stuff. I got to see a lot of stuff, but I think I walked away from that with like a confidence in my hand skills, but not a ton of other knowledge, just because I was too young.
Right.
And then that was it for a long time. I made like a couple of knives with him and then I stopped. And I was really into guitars, so I ended up working for a company who shall remain unnamed in case we talk about them in a negative light, working in a factory making guitars. And that was a relatively short period because it was a not terribly well-managed company, but they had a 5-axis CNC router that was, I don't know, it had to be like 40 feet long. Yeah, I'm pretty sure this thing was originally made for like making molds and prototypes and stuff, and they were using it for guitar manufacturing. And after I saw that thing running, I was like hooked on how cool CNC was. But yeah, again, that wasn't something that kept going. Like I worked in the music industry for quite a while. I worked for the Australian distributor of Gibson guitars.
Cool. Okay.
Yeah, I ended up as like their assistant warehouse manager and then an internal sales guy. I did a lot of repair work for them as well. Some guitar stuff, but mainly electronics like amplifiers and so on. They had this just huge pile of like trashed amplifiers. And I was like, can I try fixing those? And they were like, yeah, they're busted anyway, So yeah, and then I moved to Canada. And in Canada, for the first little while, I was just doing like construction work for cash, like under the table, And then I got into web development. Like I've been interested in programming since I was young. That started with like video games. So, I was like 14 playing video games on my Mac and worked out how I could like change the audio files for the characters so they would swear at you when they die and stuff. Yeah, and then that progressed into, enjoying programming more. And So once I moved to Canada, I actually ended up doing web development and then progressing from web development into like proper software development. I would say software engineering. Every job I've worked at, my title has been like software engineer, but I don't have any formal qualifications.
I think that you're definitely still an engineer. I wouldn't worry about that.
Yeah. Well, I differentiate because you can't go into a job interview and say like, I'm a software engineer. And they're like, cool, where did you go to university? I'm like, nowhere.
The streets.
Yeah, exactly. Well, I actually had my most recent software engineering job. I'd been working there for like 3 or 4 months, and then I was talking to the guy that hired me, who's a recruiter, and I said to him, like, oh, I think I'm one of like only 2 or 3 people in the whole company that doesn't have an engineering degree, and he was like, wait, you don't have an engineering degree? It just never came up.
You're like, no, of course I do. We didn't have this conversation.
Yeah, exactly. So I worked in a lot of startup companies doing, software engineering, quote unquote, for quite a few years. And then there was one company in particular where, early stage startup companies are a very, very stressful environment, right? And this place was really struggling to find a direction. So we had a team of like 6 software engineers. And then over the course of about 4 weeks, when we're in the middle of transitioning, we were trying to like pivot, right, from like one product to a completely different product. So like rebuilding our whole system, like mangling it until it would do this other thing. And the whole software engineering team decided this would be a good time to get the fuck off this ship,
Oh, geez.
So I ended up, I was like one of the most junior members of the team, and I ended up being the only guy left, and managed to push this product through, managed to get it launched, and then promptly had a nervous breakdown, because I'd just been like, just so stressed for like, 8 months, 9 months on top of, working in startups for years before that. So I was like, you know what, guys, I got to take like a couple of months off. I'm like, fucked right now. So I took a couple of months off. And one of the things I did during that time was got a membership at a shared workshop space, like a hacker space, a maker space, whatever you want to call it. Mm-hmm. And this place was like, it would flood every time it rained. It was like not a fancy spot, And at that space, I made some pens, I made a couple of knives, and the knives happened because a friend that I made there was like, oh, you used to make knives. Can you make me one? And then I posted a picture of that knife on Reddit, and other people were like, oh, can you make me one of those? And it just snowballed from there. And all of those early ones were literally made with like a file, like, and a drill press. That was it. There was no fancy machinery at all. And then I just kept getting more and more into it. I bought my first manual milling machine. I had a manual lathe before that. I bought a couple of really shit CNC router kits and built them. And this is like, nowadays you can get a CNC router kit that's like pretty decent for very little money. In those days, the first one that I bought was the linear rails were EMT tubing, like electrical conduit.
Oh, geez.
Like galvanized electrical conduit with skateboard bearings running on them, right?
Yeah. And I'm sure it was incredibly expensive too. I know when I first started out, I was looking into a small retrofit that was like a desktop mill, and it was still thousands and thousands of dollars, like something that would buy me a pretty good tiny desktop router nowadays.
Right. Yeah. And I don't think this was like thousands, but it was like at least 1,000,
Right.
And like the electronics for this thing, what it came with, I still remember, it was a TB6550, which if anyone remembers old school stepper drivers, like this thing was like shit, bottom of the barrel, But you know what? Like it got me into running and programming a tiny little CNC machine. And everything, as I said, everything just snowballed from there. Like I used the second CNC router that I bought to do like serial number engraving and logo engraving on the knives that I was making by hand. And then I decided to get my own workshop space so that people would stop misplacing my tools. And then once I had that workshop space, I was like, I could fit a bigger machine in here. So that's when I bought Millie, my first Fadal.
Right. So did you always have the idea in your head, like, once I get a bigger machine, I'll start doing, bevels and all of that on there? Or was there a specific happenstance or something you saw that you were like, oh, I can do the entire knife on the CNC?
Yeah, it was actually John Grimsmo. I don't know if you are familiar with him, but so he's another Canadian knife maker.
Been on the show, actually.
Yeah, yeah. So like I'm not like close friends with John, but I've met him a couple of times. He's a super nice dude. And, I saw his YouTube channel and he was making knives in his garage on a Tormac. And I was like, I want to do that. Like I'm making knives. I like CNC. Like I want to do that. And yeah, there wasn't, I just imagined, everything's easier when you haven't done it. I imagined that I was going to get this machine and then be able to like make every part of the knife. And it really took quite a few years before that became a reality.
Oh, I'm sure. Yeah. Yeah. Everything from the outside seems super easy. Oh, you just put the part in and press the green button, right?
Yeah. You wouldn't believe the number of times I've heard that on YouTube. You're cheating.
I've been told
That's
that
not
by
really knife
customers,
making.
so I fully empathize.
Yeah. And you know what? Like even at that point, like I had some CNC experience. I had some knife making experience. Even at that point, I fell victim to that thinking. I was like, oh, I'll just do it. It'll be easy. If I was a machinist before then it would have been fine. But I didn't really have that much machining experience.
So you got Millie. What How did that all play out? How long did it take you to get your first? I guess was the Mark One your first fully CNC knife, or did you have some before that?
No, I was already on to the Mark III at that point, actually. I was already making the Mark III by hand. But there's been, as I said, there's been like changes within the Mark III. So like the first ones were made black, like coated black with a high performance paint called Cerakote, which is like a 2-part epoxy. And then after that, I moved to the DLC coating that I'm still using. But those were both the Mark III. There weren't a lot of Mark IIIs that were Cerakote, like done with the Cerakote finish. And yeah, getting Millie was a very interesting process, so I initially was like, well, I obviously want like a big fancy machine, so I was looking at Haas, I was looking at Tormac, and Haas in my mind at that time was like the pinnacle. That was as high as I could have gone, and they're great machines, but now if I was thinking the pinnacle, I'm thinking like a Makino F5 or something, like very, very different class of machine. And when I went and talked to the banks about like getting a loan, they basically laughed at me. Because like my credit card was already maxed out. I didn't have a lot of credit history because I didn't own a house or anything. No real assets. I had a decent day job, but that was about it. And they were like, yeah, we're not going to give you a loan for like 60K or 80K to buy a house. Like get out of here. And then it was kind of the same story with the Tormac. So I was like, okay, like what do I do? So I started looking at used machines. And, asking on Practical Machinist and stuff like, what machines should I be looking at if I'm looking at used? And a guy that I still interact with on Practical Machinist, Bob W., was like, just buy a Fadal. Like, they're unkillable. Parts are cheap. You'll be able to work on it yourself. And I was like, okay. So, yeah, I was like looking on Kijiji, which is like, I don't know if you guys have that in the States. It's like Craigslist. And then there was a Fadal in Ottawa, which is... It's a long drive from Toronto. It's like a 9 or 10 hour drive.
Oh, wow.
Yeah. So I ended up like booking a flight, a cheap flight to Ottawa to go and look at this machine. And this company had bought 3 machines from an aerospace shop in California and then brought them to Ottawa. And they had no idea what they were doing with these machines. Like the guy that I was talking to that was demonstrating the Fadal for me, he was like, oh yeah, if you want to move your fixture offset, you just like move it in, touch off the part, and then you cold start the machine again.
Oh my goodness.
So he was like moving the actual machine coordinates, all over so he could have just been crashing it or whatever. Like the machine had no idea where it was. And at that point, I'd never seen a VMC before in person. So I'm like looking at this VMC and I'm like, I don't know, it looks good. I'll take it, And it was cheap enough that I could buy it on my credit card. And that's how it happened.
Wow. That's really cool. I mean, that's a tough... I haven't run a whole bunch of Fadals, but I would imagine that's kind of a tough situation to be into because compared to, anything Fanic or anything like that, it doesn't seem like there's a whole lot of information out there, or at least quite a bit less than, similarly aged Fanic control of that era.
Right. Yeah, I don't know. Like, I honestly, I've sort of run one Fanuc machine very briefly. I had a hard-hinge GT series gang lathe, and I hate Fanuc controls. So I'm thankful I didn't get a machine with a Fanuc control. Honestly, like the Fadals are very simple. Like they're very easy to run. And for me, as a programmer, coming from like being used to working on the command line in Linux or whatever, it's like it kind of feels like home. Well, like most people that run Fadals are like using the spacebar menus. I'm just like, typing in commands. It feels very natural for me. But yeah, it might feel odd for other people. But yeah, it was definitely still a huge learning curve. Like, there's no way that I should have paid as much money as I did for Millie. Like, I paid like $8,500 for a machine that was like 30% rust.
Oof.
And if I was like hunting for another machine now, like so I bought two Fadals about 3 years ago. I bought them for $3,900 each, two VMC 15s in relatively working. The main issue was they'd been used to machine graphite for probably the bulk of their lifespan, and the guy that was running them didn't believe in dust collection.
Oh, no.
Yeah. So restoring those two machines was a nasty process, but that's for those machines, that was a very realistic price, and I came out on top, I think, still.
Totally, yeah. Well, and one thing that I've always found really cool about the Fadals is that it seems like almost everything is an off-the-shelf part. Like, it's not a bespoke Fadal part.
Yeah.
The spindle motors, a ball door that you can buy.
Yep.
Most of the electronics are off-the-shelf relays and things like that. So it's pretty neat that despite the age or whatever the age is, like you can just go find most of these components.
Yeah, 100%. And like that's totally saved my butt. Like, because if I was trying to restore, a machine of similar vintage from another manufacturer, you'd be beholden to the manufacturer for parts. And, they generally want your firstborn child for them, right? So
Oh yeah. Yeah, when we sent our memory board in for our Kitamura, Yaskawa, who now owns Yaznek, or they bought it out, they have a flat rate across the board. No matter what they do to the board, it's 50% the cost of a new board. So I think they changed out 2 or 3 capacitors and charged us half the cost of a new board. And we're like, yep, that's just cost of doing business. It's like, oh, right. You got to be kidding me.
Yeah, 100%. Whereas like you can replace any board in the control on a Fadal for like $1,000 or less with like, either a remanufactured board or like basically a brand new one, which is pretty nuts, So yeah, it's been an interesting journey, man. Like definitely not I guess there's no such thing as like a typical entrepreneur journey, but like definitely not like a typical machinist journey.
No, definitely not. No, and especially it seems like knife making and EDC making in general everybody has a very interesting spin on how they got there. Like, I don't think I've had a single guest on here who's like, oh yeah, I was a machinist and then I just decided one day to make knives and that's what I'm doing now. Everybody's right. Like, I tried all these other things and then I finally got to where I am now. So that's really cool.
No, and it's just something I really enjoy. And like, ultimately that's why I do it. Right.
Oh, totally. Yeah. My business partner and I actually have been long before we talked or I started seeing you on Instagram. We had found your Resolutes and we were both like, I want one of those one day. These are so cool. And like, you had enough YouTube videos out and things online. We're like, this is neat. Like, you can tell through all of your website and everything how much you enjoy what you're doing, and I think that really helps sell any kind of product.
Thanks. Yeah, well, I'm glad you feel that way. Yeah, and I mean, it's lucky that I enjoy what I'm doing because it certainly doesn't pay as well as software engineering.
Yeah, I'm sure. Oh boy. So before we jump into questions, where can people find you online? Your website, your Instagram. You also have an awesome podcast that I just finished listening to, your newest one yesterday. So where can people find you?
Yeah, so my website for the knives is goughcustom.com. So Gough. On Instagram, I'm aaron.gough. I have a YouTube channel under Gough Custom as well. And the podcast you're referring to is xyz.cnc on Instagram. And that's on, all of the usual places.
Yeah, it's great too. It's a lot of fun. You and Nick have a good chemistry, and it's really cool hearing his perspective from guitar building and kind of just getting into like real industrial CNCs or I guess VMCs.
Yes, yeah.
And it's cool hearing you guys bounce ideas off each other. And wood is not something that a lot of us, at least a lot of my listeners, deal in, and so I think
Yeah.
anybody who was interested in machining wood or machining things like that should definitely go give it a listen.
Well, I'm glad you've been enjoying it. Yeah, it's been really interesting how it's kind of come about, and it's been great because so the reason that Nick and I know each other is because we shared space in that maker space, like that shitty basement workshop that I was telling you about earlier. So there was a lot of nights where we'd because everyone had day jobs, right? So we'd get there after our day job and then work until like 2 a.m. or something. You'd finish up at 1 a.m. and then get stuck into a box of wine or something. And yeah, it's great to be reconnecting with him because even though they're just down the street, I just haven't had a chance to catch up with them as much as I'd like. And they really, really do beautiful work. So
Yeah, I had never really heard of him, and then when he came on as your co-host, I was like, "Ooh, this is cool," and went and checked out, his Instagram and all that.
yeah, so if anyone else wants to have a look at it, it's Frank_brothers on Instagram, and they make electric guitars, and they just do beautiful work. I really respect the level of craftsmanship that they put into their guitars.
Totally, yeah. And then also, I love the space segments on your podcast too. So that's always, I'm a big space nerd as well. So any talk about that, I'm like, is much appreciated on my end.
Nice. Yeah, you know what, man, it's one of those things where it's I like making knives, right? But I'm under no illusions that it's going to change the world, But the manufacturing involved in making spacecraft is just mind-boggling. And for me, SpaceX really resonates because they bring a lot of the lean principles, a lot of startup thinking to that industry, whereas typically it's been a very risk adverse industry.
Totally. Yeah. You don't see NASA blowing up, 10, 20 rockets on the launch pad trying to do crazy shit. So
yeah, exactly. So yeah, it's a super exciting time to be watching that happening. You don't get to see any other companies development process. It's really exciting.
Oh yeah, totally. So
I
let's.
actually,
Oh, go for it.
just as an anecdote, so during my hardcore software years when I wasn't really doing anything else, I actually had an interview with SpaceX to work on their ERM platform, their enterprise resource management.
Oh, really?
Yeah, and we got about halfway through, and they were like, "Hang on a second, where are you located?" And I was like, I'm in Canada," and they're like, "Oh, we can't talk to you. You have to be a U.S. resident, U.S. citizen, because they do so much Air Force contracting."
Right.
I was like, "Oh man." Honestly, I'm glad. I don't have the mental fortitude to deal with the kind of meat grinder that company is.
Oh yeah.
Elon's a person driven beyond all rationality, and he expects everybody around him to be like that too. He doesn't give a fuck if you're having a bad day. He just wants you to be turning out the best possible work. So I wouldn't have lasted, and I'm glad it didn't happen. But at the same time, it was. That was one of those calls when I got that. I was like, oh my God, I've made it,
Right. Oh yeah. Yeah. I've talked to a few people who have worked at SpaceX as machinists, and they're like, you can work there, but expect to work 60 to 80-hour weeks and burn out eventually and leave the company. It's not a long-term position for most people because they just you can't keep up with that. You do it to put it on your resume and you do it to make some money and do some cool stuff, but it's a hard burn and a short burn.
Yeah, and I was already in the middle of many, many years of working in startups. I was not in a good place to be dealing with that. Because, you read, I don't know if you've read Elon's biography, but he has interactions with people at SpaceX where they're like, oh, we haven't been able to get this process working. We haven't been able to deliver on the timeline that we expected. And he's like, okay, fuck you. I'll do it. In addition to all my other work, I will do the thing you were supposed to do, and you're fired. And then he'll deliver on it. It's crazy. Yeah. I just don't get it.
I wish I had that drive at least as long and as he's had it. I have moments and months where I'm driven that hard, it feels like, but not my entire life. It seems like he is.
Honestly, I don't think it's healthy, but it's in a way we're lucky that he's decided to apply himself to something as interesting and impactful as space and renewable energy.
Oh, totally.
So, anyway, let's get back on topic. We can nerd out about space all day.
Well, let's jump into some questions. So David Ron from Patreon, he asked, do you find it harder to produce a knife with CNC than by hand? have you ever looked at an automated blade grinder for your bevels? And he also enjoys XYZ.
Oh, I'm glad. Yes, making knives with CNC is way harder than making them by hand, because when you're making them by hand, and I've made a lot of knives by hand and a lot with CNC, so I have a pretty good kind of reference for both. There's just so many opportunities to fix things as you're working when you're making it by hand. It's nowhere near as precise a process, but if something's not quite right, you just tweak it a little bit. It's just part of the process. Whereas with CNC, like, if something's not right, generally by the time it's happened, there's like no opportunity really to fix it, or you don't see it until the end of a cycle or something. And then, it's probably scrap. And I've had periods where I was learning. So when I was first starting to do bevels on the CNC, my programming knowledge was shit. My fixturing knowledge was shit. Like, I didn't really know what I was doing. And so I had the blades fixtured on an angle so that I could machine the flat part of the bevel flat relative to the machine. But because of the way that was working, and because of trying to hold the knife down at the tip, I didn't know how to do the fixturing side of it at that point. I couldn't actually machine the tip of the blade. I was only machining the flat part. So then I was having to take them to the belt grinder and do the tip of the bevel, and then try and blend it into the machine part of it as well.
Ooh, that sounds rough.
Yeah, it was not. I don't recommend that process. And because I didn't know what I was doing, I wasn't paying enough attention to like you learn over time, like where the risk points are and the things you really have to pay attention to. And I was working on a batch of 100 blades, which is, again, I don't recommend working in batches. It's something I try to avoid these days. But I scrapped like 70%.
Oh, geez.
Yeah. So, and like I have a drawer that's just full of scrap. Like I've probably got like 30 pounds worth of scrap blades, and similar in handles and stuff. And some of them are just because I'm really picky, and some of them are because it's just like shit, Yeah,
well, blade steel's not cheap either. I mean, that sucks.
Yes, yeah, and I've had a few instances like that where it's like, yeah, probably like a grand worth of blade steel that's just turned into scrap. And it happens. Like, that's, as you said, it's just a cost of like business. But yeah, I don't think that kind of a situation would ever happen making them by hand. Like you're hands-on, you would notice that much earlier, and you'd have opportunities to fix it. So yeah, in my experience, it has been a lot harder. Like obviously once everything's running, then it's easier. But the learning curve is way, way steeper, I think.
Totally. Yeah, that makes sense. And then what about a automated blade grinder, bevel grinder?
Yeah, so they have a machine in industry. So like, when you're talking like Henkel or any of the big companies, they have machines that are designed to grind bevels, and they're called a burger grinder. And often those machines are like not even CNC. They're just like cam operated or hydraulic. And they'll either grind one side of the bevel at once or both sides of the bevel at once, and they just use a big ass stone. Like they literally just spin a 2-foot diameter stone and run the blade across it.
Jeez.
Yeah, and I actually have looked into buying one of those at some point. There was a guy in the States, another knife maker, who had gotten a couple of older ones and then was selling one of them off, and I think he wanted like 20 grand for it, something like that. But like those machines are at a different level. Like you're talking like cycle times of like a minute or two to grind a bevel.
Oh wow.
Yeah, they're very, very quick. That is really designed for production. The main issue for me is just that like they're really limited in terms of the bevel shapes that you can make, and also in terms of your tolerances. Like if you look at production knives, like folding knives, fixed blades, whatever, very, very few of them are a full flat grind where you have a flat ricasso next to the handle, and then you have your bevel that goes all the way to the spine of the knife. And a big part of the reason for that is that like setting up a burger grinder to, as far as I understand it anyway, like I've never run one of these machines, right? But as far as I understand, setting up a burger grinder to perfectly end the bevel exactly where it meets the spine, particularly over a production run where the stone's wearing and like, you're kind of floating around your tolerances in between dressing cycles and stuff. Like it's basically impossible, which is why pretty much all production knives are not a full flat grind. Instead, they're what they call a saber grind, where the bevel only goes part of the way up the blade.
Mm-hmm.
And then because you're using a big cylindrical stone, most of the bevels will also be like a hollow grind. it's very difficult to produce a flat grind or a convex or, whatever you want because of the nature of the machine. So yeah, like I have considered at various points like ways to do automated grinding, but one of the things I've run into in the past is when you design a big heavy process like that, it tends to come with a lot of cost for changes. Like if you want to start making a different model of knife, or you want to tweak the bevel in some way, or make a convex rather than a flat, or whatever, all of a sudden it's like that machine either doesn't work anymore, or there's a lot of like retooling that needs to happen. Whereas machining them on the CNC, it's a programming change.
Yeah, that totally makes sense.
Yeah. So yeah, machining on the CNC is like really not optimally efficient. Like you're using pretty small tools and the cycle times are long, but it's very agile, which I really like. So yeah, I'll probably keep doing what I'm doing, just better, hopefully in the future.
That makes sense.
Yeah.
So speaking of your process, you still use A2, right, for your blade?
Mm-hmm.
So
Currently.
what, with all of the crazy new blade steels that come out, what makes you stay with A2?
Yeah, I mean, so it's interesting. If you look at the actual numbers, associated with those crazy blade steels, and there's a really fantastic guy that's been like, helping to expose this reality called Knife Steel Nerds. I don't know if you've seen Laren's work.
I've got his book.
There you go. Perfect. Yeah. So, he does like actual toughness testing, like Sharpie impact testing. He does Catra edge retention tests, which I don't think Catra tests like really reflect reality in terms of edge retention, because they don't talk at all about, or they don't address edge stability at all. But he's actually putting numbers on these steels, And if you look at all the super fancy, even the powder metallurgy, like stainless steels and stuff, their toughness is still relatively low compared to A2. And for me, the toughness is one of the main factors that drove my decision around A2, because the tougher a steel is, the higher you can push the hardness. And the higher you push the hardness, the better your edge stability is. And the stronger the material itself is, which means you can really thin out the blade bevel. And, in my mind, the perfect knife is like a single atom thick. Like
Right.
Obviously we can't do that, right? So you have to try and make the narrowest wedge possible, So that combination of hardness and toughness is really what I look for. And going forward, I've been, I'd really like to be able to offer a stainless steel. I think that's, over the years, that's really the only thing that's ever surprised my customers is, if they're used to stainless steels and then they get one of my knives, even if I tell them like, oh, you have to oil it, you have to, make sure you don't leave it in the sheath wet overnight, etc., then, some people still do that accidentally or whatever, and they'll get some rust spots on the knife and be like, oh, I don't know what I did wrong, So like being able to offer a stainless A2 would be fantastic. And the closest that I've seen to that is a really simple and fairly inexpensive steel called AEBL.
Okay. Yeah, that's what Grimsmo's using for his lock bar inserts now.
Right. Yeah. And I think AEBL was first made in like 1920. Like it's not a sexy, fancy powder metallurgy steel, but the way it's formulated with relatively low carbon content relative to its chromium content means that it has very small carbides and a very low overall carbide volume, which in turn means that it's extremely tough. So it's the toughest stainless steel for like hardenable stainless steel for knife blades by like a significant margin. And it's like 20% tougher than A2 at the same hardnesses.
Oh, wow.
Yeah, so like it's the trade-off is that because it doesn't have a high carbide volume, it suffers in edge retention when you're talking about strictly abrasive wear. So if you're just like cutting cardboard, straight lines, no real stress on the edge or anything, in that situation, the carbides in the edge really help with edge retention because they're so hard. They stop the abrasion. And AEBL suffers a little bit in that scenario. But, so I've been testing it a bunch. In every other way, it's basically like a stainless A2. I've been super happy with it so far. So that will probably be my next steel.
Will you offer both, or are you planning on a hard switch?
I think I'll be doing like a graduated switch. Probably not a hard switch. I think that like doing a hard switch is generally a bad idea if you have a product that's working fine. But yeah, I'll be like, so I have right now the only finishes that I offer are like the matte black DLC finish, and I really want to start offering my satin finishes again. The problem is that it gets quite a bit of, because it's a traditionally cast steel and then they roll it, you get areas of when they pour it into the ingot, the steel cools at different rates. The core is obviously protected by all the material around it, so the inside cools more slowly. And that means that you get alloy separating out when they have different melting points. So you end up with bands inside the block of A2 that are a higher chromium concentration. And when they roll that out, you get what they call alloy banding. So you actually get like streaks of slightly different materials, And when you're hand finishing to like a really nice satin finish, that alloy banding can actually show up.
Oh, wow.
In the finish. Yeah. And unfortunately, with A2, it's fairly common, and there's really no way to know what amount of alloy banding a particular blade has in it until I've done all the hand finishing. So you'll do like, an hour of hand finishing, you wreck your elbows, and then discover that, oh, yeah, that's not like the best blade to be a satin finish.
Jeez.
So like the nice thing is it doesn't affect the material properties. Like I've tested blades that have a lot of banding versus ones that don't have any, and there's no difference. But ABL doesn't really suffer from that issue. So I'm probably going to introduce it in my satin blades first, and then, slowly expand it as, assuming that it continues to perform well.
That's cool. That's really cool. So
yeah,
will that be a new mark, or will that just be?
Yes, that will be the Mark IV. There's a bunch of other changes that I want to roll into that. Just like little stuff. I've been working on expanding polyurethane foam inside the handle scales to expand inside during assembly and to like take away all of the airspace in the inside of the knife, so that like no water intrusion can ever possibly happen. So that's going to be a little change that I'll hopefully roll into the Mark IV. And then also hardened stainless steel Corby bolts. So the little bolts that hold the handles together. Mm-hmm. Currently, my bolts are custom made for me by a USA knife maker, and they're machined from 303, right? Because they're being run on a Swiss, like a screw machine. The issue is that the tensile strength of that material is not great, and those fasteners are really small. So I probably break like 1 in 10 during installation.
Oh, wow.
Yeah, just like accidentally over torque it a little bit and they'll just snap. I've never had one break after installation, but during installation, they're quite delicate. So what I'm going to do is increase the size of the fastener a little bit, and also change to 17.4 stainless with a H900 heat treat. And the yield strength of that material is, I think it's like triple.
Yeah. Yeah, 17.4 is pretty amazing.
Yeah, it's really nice stuff. So, and that takes the yield strength of those fasteners from 90 pounds to 900. So I don't think I'll be breaking too many of those during installation.
Yeah, I hope not.
Yeah. So yeah, and that'll let me like torque things much tighter, which helps ensure I'll have an easier time of getting the perfect fit that I want, and then with the polyurethane fill and the stainless blade steel, I think it's enough of a change to warrant the Mark IV name.
Totally, yeah. So we have a bunch of questions about rebuilding the Fadal, but before we get in that, Ben from Fort Manufacturing asked, why knives? Other than they're super cool and useful, why not another product?
Yeah, it's interesting because people that like are running a machining business, sometimes you'll see them be like, oh, job shopping doesn't pay well. You should make a product. And then people are like, what product though? So it's kind of hard to like just decide on a product and then make it successful. Like you really have to have like, a need that you're fixing for yourself. So like, eating your own dog food, they call it, like, fixing a problem for yourself and then selling that solution to other people. Or you need to have like stumbled into a successful product that you then need to like make more of, and that's kind of how it happened for me, right? Like I was making them by hand and more people wanted them. So I started making them. I think if I was in the States at some point, I probably would have gotten into like precision rifle manufacturing. I find that really interesting. But in Canada, the laws around gunsmithing are pretty prohibitive. So I don't think that's going to happen. I'm sure that there would have been other things that interest me, and there are. Like, I would really love to get into making like small scale CNC machines at some point, like mini VMCs that like sit on your bench. You know?
Yeah, you've talked about that a bit on your podcast. I'm looking forward to seeing what you come up with.
Yeah, I mean, that's been an idea in the back of my head for probably like 6 or 7 years at this point. You know, I imagine at some point it's going to happen, but you know, making a knife is like super hard, and there's only like, you know, 7 parts or something in a knife. Like, a part of me is a little gun shy about what it's going to take to like step up to something that has, you know, hundreds of parts in an assembly. But as I said, I'm sure it's going to happen at some point. Yeah, I mean, it really, as I said, it really was just like, that was what I fell into, and I really enjoyed doing it. So there hasn't been much pressure to make me stop, you know. I do think over the next little while that I'll be starting to do composites manufacturing.
Oh, cool. Because you just started doing pressure casting, right?
Yeah. So I've been pressure casting like really high performance glow in the dark materials for my knives, which has been super cool. And I've had inquiries from other people to, you know, make that stuff for them. And initially I was like, no, there's no way that I can do that and like make any money. And then I was just like, okay, but how about if they cost this much? And the people were like, oh yeah, that's totally fine. I was like, oh, okay. I could probably do that. So I really want to muck around with making G10, which is a fiberglass and epoxy composite that we use a lot in knife making. Just because there's like no way to get a custom color of G10 unless you buy like a pallet of it. You know, you're buying like 20K worth of G10 to get a custom color. And I've been working on a really small scale process that would let me do custom colors in like a single sheet.
Cool.
A 12 by 12 inch sheet. So that's probably going to happen over the next little while, mainly for my consumption to begin with, and then I'll probably start selling it. Yeah, I mean, as you know, it's just what you fall into, I think, a lot of the time.
Yeah, that totally makes sense. So the biggest question, let's see, we got Ben from Fort Manufacturing asked, what did you learn from rebuilding your Fadal? Would you do it again knowing what you know now? Why and why not? How did it help hurt your business? Jake Giles asked, what's the 2 most valuable things you learned while rebuilding your Fadals? Brighton Manufacturing asked, why did you choose to refurbish your older machines rather than start with a newer VMC, which you kind of already answered? And Moose Engineering asked, how instrumental was rebuilding your Fadal to starting the business? So everybody wants to know all about the Fadal rebuild. So let's dive into that, because it's a great YouTube series. It was super cool to see somebody, you know, just tackle such a large scale rebuild process like that. Let's go into all that.
Sure. Yeah. And I mean, as I said, like, it really was by necessity. Like, you know, when you have the banks laugh at you because you're like trying to buy a new horse, you're like, oh, okay, so what are the options then? So yeah, originally it was by necessity, and I really went into that with my blinders on. You know, I had no idea what I was doing. In the past, as I said, I've done a fair bit of like electronics work. I used to build guitar amps as a hobby. I've worked on guitars and cars and, you know, all sorts of weird electronic stuff. But aside from that, like, I didn't have any. I guess I built my CNC router kits. I guess that kind of counts as well. So, you know, I knew what an axis was. I knew what a servo motor was, but like, I'd never, you know, tuned a servo motor. I'd never like had to replace a ball screw or anything. And then, yeah, going into that machine, I think it was both. So like, my business wouldn't exist as it is if I hadn't have done that. And yet it was also kind of a terrible idea, you know, because like, when I got Millie, as I said, like, so Millie's spindle was like badly bell-mouthed. Like, the taper in the spindle wasn't in good condition. The ball screws on one of the axes had like 5 thou of backlash.
Oh, jeez.
Yeah, it was like really, really rough. But funnily enough, like, the Fadal control will let you dial in like 5 thou of backlash compensation. Like, I can't imagine too many other machines where you're like, oh yeah, I want to be able to put in 5 thou of backlash comp, and they're like, oh yeah, that's totally a good idea.
Right.
You know, like, when I bought Millie and I looked underneath, I got her back to my shop and I was working on her, and I looked underneath, and someone had over-greased one of the carriages on the linear rails and busted the end cap off, and a bunch of the like ball bearings were falling out.
Oh my goodness.
You know, so that machine was like, I don't think I would buy that machine now, certainly not at that price, you know, but it ran and I could machine stuff on it, you know, and that was like that was a game changer. But I was doing everything by hand before that, you know, so there was a lot of like unexpected surprises with that machine. And I probably ended up spending, I'd say $14,000, something like that on the restoration, because it was like new bowl screws on every axis, new thrust bearings on every axis, a new spindle drive, although that was a bit later. Yeah, like there was a lot of parts put into that machine.
Jeez.
Yeah, but at the same time, as I said, like I was able to put it on my credit card and then use it for. I got it running. I used it in. I did like the initial restoration, which I would call more like emergency maintenance rather than a restoration. It was like I made it look pretty. I did a lot of paint. I replaced weight covers and stuff. Replaced like the spindle fan wasn't running.
Oh no.
Like that's a bad one. The spindle fan was so gunked up it wasn't running. The fan in the back cabinet was like intermittent because it was so gunked up. So I went through and replaced all that kind of stuff, made sure the machine wasn't going to get worse, and then started running it. And like it literally paid for itself after I got it running. It paid for itself probably within like 6 or 7 months, which is pretty nuts for a machine purchase like that.
Oh yeah, that kind of return is pretty amazing.
Yeah. So, but there were certainly times when like the machine went down and then was down for like, 3 weeks or a month, because like I think the longest downtime was when I had the spindle drive go unexpectedly. And again, they'll remain unnamed. I bought a spindle drive replacement. There's a company that was selling Yaskawa drives, quote unquote programmed for these machines. And like they sent me the wrong spindle brake resistor. And, I'm reading the manual and I'm like, oh, it says this should be a 12 ohm spindle brake resistor. And you sent me an 8, is that fine? And they're like, oh yeah, 100%. It's totally fine. And then like the first time the spindle tried to stop, the like brake circuit shorted out and it started just dumping the full line voltage into the brake resistor.
Oh no.
So the brake resistor literally like glowed red hot, caught fire. There's like smoke coming out of the machine. The brand new spindle drive that had done like literally a minute of test run was toast straight away. And then they sent me another replacement, and guess what? That one got toasted too, despite me protesting that like maybe they should change the setup. And then once it did finally get running, I found out that they were programming that spindle drive for volts hertz operation, not sensorless vector operation. So it took like 30 seconds to get the spindle up to full speed.
Oh my goodness.
So there's definitely been some speed bumps. Yeah, it's one of those things, like if you have a product that's like in super high demand and that you can make money if you can just start machining it like right now, don't buy a used machine. Like finance a new machine and just get busy making your product, right? But like if you're still in the process of like spinning things up and you're working a day job and you've got like, cheap space like in your garage or something, then like a used machine's honestly a pretty good option.
I completely agree.
Yeah.
Definitely. So what are the 2 most valuable things you learned while rebuilding them, do you think?
I definitely know my way around those machines now. I think that in of itself is a very valuable thing because they really do form a big part of my livelihood.
Yeah, you are your service tech.
Yeah, 100%. And there's very, very few things that I can't fix on that machine, potentially within an hour. Like I keep curated assortment of spare parts on hand. And because both of the machines are actually identical mechanically and electrically, I have the same fixture plate set up on both of them, so I could just swap fixture plates from one machine to the other and then run the same programs. I actually keep the tool magazines set up the same between the two machines, so I can just like literally, 10 minutes move the fixture plate over and be running on the other machine. And then, start dumping spare parts into the busted machine and fix it up. Though granted, I haven't had to do anything in like, with Millie, it's been like literally years at this point since I've had to do anything. Like, I guess she's had the screen replaced pretty recently, but like that's a fairly unintrusive thing to have to fix. Like a 25-year-old CRT monitor going out's not all that surprising. So yeah, I think just the familiarity of the machine with the machines would be my first thing. And then second thing, most important thing that I learned during that time, I think is just like mechanical competence. I really did learn a lot of stuff during that time. And I don't think I would be intimidated by like taking anything apart at this point. If I was to if someone was to like sell me a used injection molding machine, I had to like fix it. Like that's going to be like a bumpy road because I'm going to be learning a lot about that specific machine as I work on it. But I'm not going to be intimidated by working on a machine like that.
Have you thought about doing any of the controller retrofits that like CalMotion has?
Yes. So the CalMotion retrofit, the 527F, is basically like a hot rodded version of the original Fadal control. From like speaking to sources there and some sources elsewhere, my understanding is that they're literally running like the original Fadal code under the hood.
Oh, really?
Just on much faster processors and with some like stuff layered on top. And then one of the other options is the next gen control, which is made by fadalparts.com. And the owner of that company, Dave DeCourson Jr., is actually the son of one of the Dave that is the D in Fadal. So yeah, like he spent a lot of time in the company working on those machines, and his retrofit is, kind of meant to be a serious upgrade. The main issue there is just that it's a substantial chunk of cash. I think it's like $12K US for that retrofit.
Ooh, that is rough.
Yeah, I mean it's fine. Like if you are making a bunch of money off your machine and you just want to make money faster, then it totally makes sense. For me, the machines aren't necessarily the bottleneck, which means that it would be kind of like a quality of life improvement, not like a cash improvement. The main hindrance for me is that at this point, if I was to do a control retrofit, I really want it to be something that I can like take apart and modify and get into the guts of if I want to, and neither of those retrofits really offer that. So yeah, I've been looking into other stuff like the Dynamotion controls. Linux CNC, of course, is like a pretty popular one. At some point there will be a retrofit, but it's not going to be, it's going to be a bit of a weird one, because so basically what I'm thinking about doing is the Fadal control operates on what's called an S100 backplane, which is like a super old computer, information exchange backplane where all the cards like plug into it and then the different cards talk to each other. Mm-hmm. But on the right-hand side of that backplane, there is what they call the mill interface card. And that card literally talks to like all of the relays and the all of the contactors and stuff that control the machine. So if you can design a drop-in replacement for that card, then you basically get like all of the input-output spots that you need for a retrofit in like a single plug-in location.
Oh, that's handy.
Yeah. So what I would like to do is reverse engineer that, have some boards made that I could then, basically put like Linux CNC installation with one of the Mesa hardware motion control cards, mm-hmm. and then like, an input-output board that like literally plugs in. So you basically unplug the Fadal boards and then plug in like a retrofit set of boards, because that way for me, the risk is really low. Like I don't have to destroy the machine in the process of retrofitting it,
Right. Yeah. Worst case, you just swap it back and call it a day.
Yeah, exactly. And that's driven by me. Like I need the machines to make money off, whereas a lot of guys that are retrofitting machines, like they bought a machine cheap at auction, they want it in their garage. And, in some cases, like people are retrofitting like Fadals that are working 100% correctly with like Linux CNC, because they know that it's newer and better, quote unquote, but like the original Fadal control is totally fine. The only reason I would look at a retrofit is just because the requirements that I have for Surface are really, really tight. And not in terms of tolerance, but in terms of consistency. Like I want to be able to, 3D contour a curved surface and have every pass be in exactly the perfect spot to minimize the need for hand finishing and so on.
Right.
And the Fadals are not quite up to that, to be honest. Like the resolution of the resolvers, like the literally analog encoders on these machines is not great. I think it's only 2,000 and something steps, or like, discrete intervals per rotation of the ball screw. So like the actual like resolution of the control on each axis is like a tenth, whereas a modern machine would be like 10, 50, 100 times that.
Right. Yeah, because those are like sensorless homing too, aren't they? And
it's not quite sensorless. So basically what it does is like you put it in the middle of the rotation cycle for one of the resolvers on each axis, and then it looks for the tachometer pulse, which is kind of like an index pulse that happens once per rotation of the ball screw. So it just oscillates back and forth, looks for that tachometer pulse, and then uses that as like the the reference point for home, which is actually really clever because then you don't have any like home or limit switches to go wrong. The issue is that, you know, as I said earlier, like someone that doesn't know what they're doing with a Fadal can put the home position anywhere and then crash the machine into its hard limits without the control even knowing that something's going to go wrong.
Yikes.
Yeah, which is not great. But it overall, it's a pretty... I like solutions like that. It, you know, it minimizes the number of parts needed. It's very simple. You just have to be a little careful.
Yeah. So how about memory? Because you hard mill all your blades too. So I would imagine those codes are fairly large.
Yeah, I think my smallest production program's like 20 meg, something like that. So not small. And yeah, I use the CalMotion DNC boxes to like drip feed all of my code.
Okay. That makes sense.
Yeah. And that runs great. No problems at all.
Yeah, we've got one on our older brother, and it works fantastic. I'm a big fan of them.
Yeah. Yeah, and like originally I didn't have that, and it was obviously a real limitation. But yeah, since getting that, like zero regrets. I really don't need anything more than that.
Yeah, I will say I wish I had sprung for the network box over the USB one, because like our other brother's on the network, and it's a lot easier to just send programs over that way. And if I could have just had both of them accessible for my desktop without running a USB between them, I was like, I wish I had done that in retrospect. But
yeah, that's fair. I mean, I'm like literally 4 feet from my machine right now, so USB isn't really a hardship for me. But
it's I mean, to be fair, I'm talking about saving myself like 10 steps too.
Yeah.
But just as a quality of life thing, it's like they aren't any more expensive, the land CNCs versus the USB one, or maybe it's like $50, and it's like, at the time I didn't have the forethought to be like, oh, maybe I should just do this. This will be easier.
Yeah, I mean, I haven't experienced that either, right? So like probably if I actually had experienced it, I'd be like, yeah, of course I'm never going to use USB again, but you know, it's fine.
Yeah, totally. Let's see, what else? The Pragmatic Machinist didn't have any questions, but he just wanted to say your YouTube videos are top notch.
Thank you. It is insane how much time they take up. It's really, when I look at like how much time I spend making each video, it's a little bit brutal. Like this, I think it's probably like 8 hours of editing for like, if I was to make a 6-minute video, it's like 8 hours of editing probably.
Oof. Well, it's much appreciated because I too enjoy your YouTube videos.
Well, I'm glad you like them. I'm glad that people like them. I mean, that's why I keep doing them, right? It's the interactions around them are really nice.
Awesome. And then one question that came up from TIR Services that I thought was a great one was, what lessons have you learned by growing and then downsizing your business? And we haven't gone over all of that, but I'd love to dive into growing it, and then you also moved the shop and then downsized a little bit, and what decision-making process behind that was, and all of that.
Yeah, so actually I have a YouTube video that talks about this a bit, but yeah, I think it's a really good question because I don't know, like, you know, in modern society, particularly because a lot of like business practices are driven by people with MBAs, you know, that have never actually started their own business. They just come out of school being like, growth, you know. It's a bit weird to like downsize a business, particularly out of choice, you know, not necessarily by necessity. And for me, it really comes down to quality of life. Like my mental health really suffered when I was trying to upsize, you know, because I went from a shop where it was just me and my rent was like $1,500 a month to having fixed expenses of like over $9,000. And I could just never get that out of my head. It just felt like it was hanging over me like a, you know, like a big anvil or some shit on a rope that's halfway worn through, you know? So it really stressed me out all the time. And the level of stress was so high that my productivity just went to shit. You know, I had so many days when I was just, you know, like sitting at home, completely unmotivated, completely stressed out, when I could have been making progress in the business. And it just didn't happen because of the like mental cost of that situation. So I think for other people, it would have been 100% the right move. You know, like I have a friend, Will, that runs a company called Tactile Turn down in Texas. Mm-hmm. And he's, you know, extremely aggressive about his expansion kind of process. And, you know, like it's nice. I think he has the cash flow to back that up. You know, like it's not like he's like losing money. And then, you know, John Grimsmo is like that as well, just incredibly aggressive with the kind of expansion that he's looking to do. And, you know, as I said, for some people, that's totally the right move. That's what fires them up. They're like really excited about doing that. And I thought that it would be like that for me, but it just wasn't. It just ended up being a detraction rather than an addition, So that was really what drove the change, is that I just really wasn't enjoying myself at all. And, like what running your own business is so stressful, even when things are going well. Like, why would you want to do it if you're not enjoying yourself? So yeah, I decided to scale back. I had one part-time employee at that point too, Mike, who is like, he and I got really close during that time, and we're still fantastic friends, which is awesome. I'm glad that didn't, our friendship didn't suffer because of that process. And yeah, it was a really difficult and painful decision and process, but 100% I would do it again.
Yeah, that sounds more than worth it.
Yeah. I mean, like now, so I was a bigger shop. So I got a shop. I went from a shop that was like 500 square feet to a shop that was 2,500 square feet. And there are massive inefficiencies that introduces. Like, you have to walk way further to get to stuff, which doesn't sound like a big deal. But like, if you're walking 20 times a day from like the machine to a bench or something, it adds up. It makes it feel very like, inefficient.
It definitely is. I've got a friend in Chicago that runs a business, and he's got a pretty large warehouse where they assemble things. And he got everybody, well, not everybody, he bought a big handful of scooters, and then all these scooter docks, so that people can just grab a scooter wherever they are and scoot across the warehouse, because he saw the same thing. He was like, I'm tired of people wasting 5 minutes a day walking across the shop. Like, it's stupid.
Yeah, 100%. Well, and the other issue for me was that, so I'm in Toronto. It's like an incredibly expensive city. And like, if I want to get a car here, it's going to cost me like $500 a month in insurance. Oh. And then, you have to actually pay for the car as well, right? So I always just catch public transport everywhere. And to get to that shop was like almost an hour on public transport each way. So like, not only does public transport suck, but you're spending an hour or 2 hours on it a day. Like, that was really... Initially, I was like, oh, it won't be that bad. And then by the end of the year, I was like, fuck this noise. Like, I don't want to do this anymore. So, yeah, like, my current shop that I'm in now is much smaller. It's only 500 square feet, but I've managed to cram 2 Fadals in here. And I've got a manual lathe that I just bought, 3D printer, grinder, vibratory tumbler, my sandblasting cabinet, bunch of benches. And it feels spacious. And it's a 20-minute walk to get here. And I walk through a park. It's just the quality of life is much, much better, and like it's very applicable right now, because like the last month for me, for whatever reason, has just been really slow on sales. And when I was in the big space, that would have been like I'm literally going backwards $9,000 in that month, and whereas here it's like $1,600,
Right. Yeah, it sucks, but it's not like you're not feeling the stress creep up as much as you would.
Exactly. So yeah, I think overall it's been a really positive change. I think the next level of positive change is going to be for me to get outside the city. Yeah, my girlfriend and I have been talking about this for quite a while, but we're, sometime in the next couple of years, we're going to buy a property outside of the city with either a big shop already on it or build a big shop. And then like there'll be all sorts of like productivity that I'll gain from that. Like I can, sit inside on my ass drinking a beer and watching TV, and then go outside and like change parts and run another cycle at nighttime.
Oh yeah. Yeah. I'm definitely jealous of those who have their shop in their garage or in an outhouse or something. Like, Drew, one of my friends, not from Drew Fab, he's got his in his garage, and he was talking about, working at home at his day job and then looking through his window and seeing his shop. And it's like, I would love that.
Yeah, and that totally opens up other possibilities. Like you just said, I could work like a software engineering job and then be like, oh, I need, a smoke break, and actually be like changing parts for another cycle in the shop. And then, my cycle times are like 3 or 4 hours, right? So like I could just be getting like, 18 hours of spindle time a day with, like 20 minutes of hands-on time. So yeah, there's a ton of advantages to doing that, in addition to, like, I still pay a bunch of rent here. Like $1,600 just for the rent isn't horrible, but you add like power and insurance and stuff on top of that, and it's that's like most of a mortgage probably on a small property. So that's probably going to be the next step, I think.
That'd be great. Yeah, that'd be really cool.
Yeah, fingers crossed. So yeah, I mean, as I said, I have a video on YouTube where I talk a bit more about the upscaling and downscaling process. And yeah, I don't have any regrets. Like, I don't have any regrets on either side, really. Like, I think I needed to try scaling up, but I'm glad that I ended up making the decision not to go with it. I think that there can be a lot of shame. Like, people feel like they've failed. Oh, I've worked to get here. I shouldn't scale down. But like, you have to do what keeps you sane, what makes you happy.
Yeah. Well, I think, the current fad is this grind culture, and,
Yeah.
you got to work your way to be a billionaire kind of thing. So I think there's a lot of, like you said, shame associated with that. Like, they see it as a failure rather than, oh, I tried something and I prefer the other one.
Yeah. And for me, I think that was a really good lesson that came out of working in startups. Like, failure is always an option. And like I say in the video, like, one of the things that I took away from working in startups was this mantra of fail forward fast. And people that have always worked in like old school traditional companies, they hear fail fast and they're like, oh, you're just like, why would you want to fail? You're just giving up. You're just breaking shit just because whatever. But like, the whole point is you try something, there's a possibility of failure. If it fails, you should let that happen quickly and let those lessons drive you onto the next iteration of that thing, or deciding that it's untenable.
Exactly. Yeah. My first boss at the first shop I worked in, I was so careful for the first, I don't know, 6 months or I can't remember how long it was before he said this to me. But one day he took me aside and he goes, can you hurry up and fuck up already so I can start trusting you? He's like, right. You're going to make mistakes and I want you to make them now while you're being careful and while you're doing small things, because the mistakes only get more and more costly from here. He's like, just hurry up and do it so that I can start giving you more to do.
Yeah, totally. Like, you have to be able to like look at a situation, identify the risks, accept them or not, like, redesign or not, and then learn how to deal with the outcomes of that. Like, obviously you don't want to be doing that if you're like sticking your hands in a machine while it's moving or some shit. Like, there are obviously limits, but like, yeah, like, failure isn't something to be afraid of, I don't think.
Definitely not. No, it's only a failure if you continue to make the same mistake over and over and over. Like, yeah, I know that's super cliche to say, but like, that really is the only way to turn a failure into an actual failure, is like, not learning a single thing from it and just blindly going into the next failure.
Yeah. And I think that's exactly how I would phrase it. If I had stayed with the scaled up business in the bigger space, then I would have been like signing up for yet more failure. I would have been like unhappy and stressed out the whole time. I probably would have closed the business. That would have been the outcome of it. I would have been like, fuck this. I hate doing this. I'm gonna close shop.
Yeah. Yeah.
So in this case, like, admitting defeat and just moving on was absolutely the healthiest thing that I could do.
That's awesome. So real quick, before we jump into shop new things, you touched on 3D printing. What printers do you have and how are you using them in the business?
So at home, I have an Anycubic Colossal Linear Delta Plus, which is quite a mouthful. That's just an FDM printer. It's a Delta style FDM printer. And at the shop, I have an Elegoo Mars 2 Pro, which is a resin printer. And honestly, like, neither of them are integral to my business, but they are very useful for some stuff. Like, so my FDM printer at home, I have used that to print like organizational stuff, like little caddy for precision screwdrivers. I've got a caddy on my VMC that holds like torque wrenches and a drill and like all that kind of stuff that's all 3D printed. I think the FDM printers are fantastic for that kind of stuff, where it's like, it doesn't need to be the strongest thing ever. You just want like something in a particular shape now,
right?
Because like, setting up a VMC to like machine this caddy for my, like, it's just, that would be dumb,
right?
It wouldn't be worth the effort.
Here's your $100 caddy.
Well, yeah, I don't think I could make it for $100. Like, how many hours of like you spend an hour programming? I mean, I'm slow. I'm not a job shop guy, right? So I'm not particularly fast with new setups. But like, let's say it's like an hour programming, 15 minutes in CAD or something, and then like 2 hours of machining, like, plus materials. That's like a $300 caddy,
Right.
Yeah, so it really, really great for that. The Delta printer is not the most accurate thing in the, like the kinematics of that kind of a system just don't terribly lend themselves to being super accurate. And I do wish that I had a more accurate FDM printer.
Well, because you tried sheaths on there, didn't you?
Yeah, that's going to be a video. I have so many 3D printed sheaths. So many. So I have like FDM printed sheaths in like 12 or 13 different materials. I have multiple SLS printed sheaths, like laser sintered out of nylon. I have multiple resin printed sheaths on different machines with different resins. I spend a lot of time trying to see if that could work because it really would be super nice. And like I probably spent like, I would say a week of CAD time at least, just getting to the point where the design of the sheath worked. Because it's actually a really complicated shape. Like you're basically making like a spring out of plastic that has to fit a knife inside. You know, it deforms when the knife is being pushed in and then it snaps back into place to hold the knife in place. But you can't break it. You know, it can't be like delicate.
Right.
Yeah. So, and the end result of that is like, you know, the SLS sheaths, as they wear, they release nylon powder and they turn white. You know, like they look like shit.
Oh, interesting. Okay.
Yeah, the resin printed sheaths kind of do the same thing. Plus, they creep. So because there's like a little bit of spring tension left in the lips of the sheath as they're hanging onto the knife, that the resin material, it just tends to creep. So it loses its springiness over time. And it's kind of more delicate than you would like anyway. And then the FDM sheaths, like the material properties are actually pretty decent, but they're not quite good enough because you have like the weak layers going through a direction that you really don't want to have weak layers. Mm-hmm. And then the aesthetics just aren't good enough for like, you know, product that's going to go to customers. So I think ultimately that process was a failure, but you know, I learned a lot about 3D printing doing it. And I now use 3D printing for other stuff because of that process, you know?
That's cool. Yeah. I would have instinctually thought that SLS would have been the best choice, but I've never worked long term with anything that has been SLS printed. So
yeah,
that's interesting to hear.
Yeah, SLS looks fantastic. Like I think it's the nicest out of all of them, you know, because it has really nice like kind of rough surface texture that hides layer lines and stair stepping and all that kind of stuff. Mm-hmm. But yeah, as I said, like the problem is when you're like you've got, you know, the knife handle rubbing against the sheath every time it's inserted and withdrawn from the sheath. And SLS material wears by like turning into powder. So you get this like nasty white powder that ends up like covering the knife. You know, maybe a different SLS process would work better, but like those were printed on like a Canon EOS SLS printer and then like in a white nylon 6 powder and then dyed. So like that's probably one of the nicer processes you can get, you know?
Yeah, it definitely, I don't think it gets better than that. The reason I talk about it is I just got a test print from a Fuse one of the Formlabs ones, and I was really impressed with like the quality and all that. And I was like, oh, I wonder, you know, if that would work for something like that. But apparently, yeah, I didn't think of the wear properties of like, well, it just turns back into what it started as, you know, nylon dust.
Well, I've been waiting for the Fuse one to come out for the longest time, you know, and they originally said that was going to be like 10K US, and I think it's a fair chunk more than that now. I think it's like 16K or something.
Yeah, well, I think the base machine is still 10K, but like you have to have the reclamation unit as well, and that's like another 5 or something like that.
Yeah, I'm just double checking it now because I think it was more expensive, which is yeah, starting from 18,499.
Oh yeah, I just pulled it up as well. Jeez.
So you know, it's like almost double what they were originally saying that they were.
Oh yeah, complete setup starting at 31.
Yeah,
which is still, I mean, compared to some of these other machines, a good deal, I guess. But like, That's not 10K. That's not anywhere near 10K.
No, and it's also like really difficult for me to justify if it like might not work.
Right.
Right. So yeah, I mean, right now one of the things I'm working on is an automated sandblasting cabinet, which is going to be a super fun project. Like pretty much all of the design work on that is done, and I'm going to be moving into like getting parts laser cut, like steel sheet parts laser cut for that soon. And then I've been 3D printing a lot of the internal parts. I didn't think that like FDM printing would be up to withstanding that kind of environment, but you know, I printed some parts just out of like shitty PLA and left them in my blasting cabinet, and like you can't even tell. They look just totally fine.
Oh, really?
Yeah. So the only problem is that so there's a really, really nice material that I've been printing, which is carbon fiber reinforced polycarbonate copolyester copolymer. So that's a bit of a mouthful.
I bet, yeah.
Yeah. So like that's an awesome 3D printing material, but it's like really, really hard to print, and you need like a full enclosure and high temperatures and all this kind of shit. So basically, they've made like an alloy of polycarbonate and copolyester, which tames a lot of those difficult properties while still giving you a lot of the benefits of polycarbonate. And
cool.
then I never would have thought this previously. Like, so for anyone that's new to 3D printing, when I first got into it, I was like, oh God, like carbon fiber reinforced parts, I've heard they're really difficult to print. I'm going to stay away from that. I'm going to try and print like plain nylon, plain whatever. Yeah, don't be scared of the carbon fiber reinforced materials. They print way nicer than their unreinforced counterparts. Like way more nicely.
I was just hearing that from somebody recently. They were like, oh yeah, I print everything in nylon X. And I was like, isn't that really tough to print? He's like, no, it's super easy. Like, it's a higher nozzle temperature, but nothing that like even Ender 3 can't do.
Yeah. And like, I don't know, the carbon fiber seems to like totally tame warping, tames bridging, like, stuff that's like, like I've tried a bunch of times to print unreinforced nylon on my machine, and it just doesn't happen. Like I don't get any layer adhesion. The parts warp. Like they're just shitty and horrible. And that's after like one time I dried a roll of nylon for like 14 hours in my oven to try and like, I was like, maybe this is a moisture problem, No, it still prints like shit. And then, carbon fiber reinforced nylon straight from the package, like no drying, no nothing, prints beautifully.
That's crazy. I'm going to have to get some and give it a shot.
Yeah. Yeah, it's really, really worth it. So like there's a company up here in Canada called filaments.ca, and they have this carbon fiber reinforced polycarbonate that I was talking about. And this stuff is, in my mind, it's like as close to the perfect FDM material as I've seen. And at this point, I've probably tried like 20 different materials. And so I was printing all these parts, and it's not expensive. It's not super cheap. It's like $50 a kilogram, which is not horrible.
No, it's not terrible at all.
And that's Canadian too. So, you guys down in the US can get the currency discount. But I printed all these parts out of this nice material, and then realized that my Delta printer hadn't been holding tolerance as well as I thought it
would. No.
So I've got like $150 worth of parts needing rework or scrap parts sitting on my desk at the moment, which is kind of taking the wind out of my sails a little bit on this project. But yeah, I'm going to get back to it soon. And for stuff like that, 3D printing is just so useful. Like you're going to make one of something, and the material properties of a good quality 3D print are like fine, then like go for it, man. That's awesome.
That's super cool. I'm glad to hear that. I'm definitely going to have to buy some and give it a shot, because right now my go-to has been PETG, just because it's fairly easy to print and some pretty decent properties, but it'll still break under any kind of moderate load. So
right. Yeah, and so they do like carbon fiber reinforced PETGs, and they're supposed to be really good. Like they make it even easier to print, and then you get much higher stiffness and a really nice kind of like matte surface finish. But yeah, like for me, the sweet point seems to be like materials that'd be kind of floppy and bendy if they weren't reinforced, and then you put carbon fiber into them, and they end up being like stiff but like tough. Like carbon fiber reinforced PLA is like the most horrible shit. Don't bother with that. It's just so delicate.
That makes sense. Yeah, I mean, PLA is already so brittle as it is.
Yeah, but like something like PTG with carbon fiber reinforcements, really, really nice.
Okay. Yeah, I'm definitely going to have to try some then.
What were we talking about? Sorry, we had a whole thing before this, didn't we?
No, that was it. I was asking about 3D printers and your business, and that was right along with it. The other thing I wanted to ask you about is how dirty did it feel to machine your machine table for your fixtures?
I didn't do quite as nice of a job of it as I could have, to be honest. So, I did that early on in my machining career, and I drilled the holes with a drill and then reamed them. And everyone will be going like, oh God, what about the positional tolerance? And yeah, 100%. Like if I was doing it again now, I would like helically interpolate those holes with an end mill, and then I'd probably helically interpolate to size actually, because you can really like sneak up on a size doing that, But I don't regret it at all. Like it works beautifully, And so I've done that on like the newer Fadal that I bought, I did the exact same thing. And then I just have like, you can get those dowel pins that have like a threaded hole in one end.
Yeah.
To pull them out. So I just, whenever I'm not using the fixture holes, I just like, or the dowel holes rather, I just plug them with a couple of those, like if I'm using a vise or something. And then, yeah, like all of my fixture plates have that on there. I can just change plates within like a minute and never, the only time I ever set up an offset or like measure the position of stock is if I'm using a vise, and that's like a couple of times a year. The rest of the time, all of my fixtures, everything, all happens off the same work offset.
That's pretty handy.
Yeah, it's really nice.
Yeah, that's really nice. All right. Well, yeah, that kind of was the last thing I kind of wanted to talk about, because I've heard you drop that nugget throughout your podcast and videos, and it's always like, I'm finding in my career as I move through it that like I'm getting less and less gun shy of modifying things that you think of as sacred, like vices or work holding, but it's still, there's that little bit of you that's like, oh, milling into the table, no, you shouldn't do that. Like,
well, I'd feel a little bit more gun shy if I was like buying a Makino and then that's the first thing I do to it. But like these are Fadals, like I'm not, they're mine. Like if I'm selling them to someone and someone's like, what, did you drill a hole in the table? And I was like, because it worked better.
Right. Yeah.
Like, it's a tool. Modify it so it works better.
Exactly. Well, and to be fair, a little story I'll share is there's a shop. I'm not sure if he's still around in Tucson, but we had gone there to buy our lathe from him, our manual lathe, and he was showing us. He had 3 or 4 Fadals. They were the 60-30s.
Yeah, nice big ones.
Yeah, but one of them was so clapped out. He goes, oh, yeah. It had some really bad error in Z on the table, so I just milled the whole table flat. And both Brad, my business partner, and I just cringed so hard, and we're just like had to turn away from him because we were cringing so hard.
Yeah, that's there are proper solutions as that. Yeah. Yeah, I mean, I will say, like, if anyone's thinking about it, like, you don't necessarily have to machine holes in your table, but if you put down a fixture plate, mill some location holes in that, and then set up all of your work holding so that it mounts to that. Like, imagine you've got like a couple of vices that have like locating pins on the bottom. You can chuck them on the table. Your vices are modeled in your CAD, and you can just like build a setup in CAD. So for me, the fixture offset for all of my production stuff is dead center of the table at the surface of the table. And then everything is, offset from that in CAD, right? Like I just have one fixture offset. But like imagine just being able to chuck a vise on your table. You already have it modeled. You put your stock in the vise in your CAD model and then set that as your work offset, and you just like never have to measure stock location again.
And I think the industry in general is going that way, 0-point fixturing, and there's, I don't know, 5 or 10 companies now that all have their own version of that, but it's such a big reduction in setup time.
Yeah, 100%. Yeah, I mean, that's honestly like that's the one thing I haven't done is made a fixture plate for my vise. So like I still have to square my vise up every time I put it on. I know I really should do that, but like I just don't do enough onesie-twosie stuff to make it something that's like really been painful.
Right. I mean, you just said you only use it a couple times a year, so
yeah,
that's definitely not a pain point.
Yeah. So
that's pretty cool.
Yeah, drill some holes in your machines, man.
Well, this jumps us into shop news or new things. Is there anything else that we didn't cover that's new in your world or new coming into your shop?
I'm working on kitchen knives at the moment.
I was just seeing those on your website. They look great.
Thank you. Yeah, so like the one on my website is like totally handmade. That was like an original prototype. Just because I find that like hand making the first version of something, like knives, you've got your hands on them all the time, right? So just designing one in CAD, for me at least, never really seems to work. Like I always want to like tweak it. So I did the first ones by hand and then made a CAD model from that. So yeah, I'm going through the process of doing like the production prototyping now. Built all the fixture plates, and I'm doing like the first machine. I'm on my second blade. The first one was like total atrocious pile of scrap. The second one is like maybe it'll be a knife. So yeah, it's been a really interesting challenge because it's like I would say a third of the blade is thinner than 20 thou
Wow.
in Z. So yeah, like that's a very thin section to be like hard milling, you know?
That's rough. Yeah.
Yeah. So it's been a learning curve so far, but I'm making progress. Like things are going pretty well. And yeah, it's totally different fixturing. Like I'm basically window machining this whole thing. Yeah, so I have like a first op station that is like literally just like a flat steel place, with some bolts that hold down the raw steel stock. And then on that first op, I'm machining a couple of dowel pin holes, and then I flip it and put it onto a second station that has dowel pins for location, machine the backside, and then I'm window machining, like, cutting that out, but leaving the periphery oversized, like the outline oversized. And then I have a third op that is just going to be a trimming. So I have a bunch of clamps that come in over the top, hold the blade down, and then I'm machining like the outside periphery of the blade to final size. And then also machining the pinholes in that same operation, so I can ensure that the locational tolerance between the pinholes and the outline of the knife is like as tight as I can possibly make it.
Right. So less finishing when you put on your handles.
Yeah, exactly. Well, the goal is like zero finishing on the periphery of the blade when I'm adding my handles. So yeah, like that's a really, really different process for me compared to how I make the Resolute, which is all like hard fixturing, very specific to the exact shape of the knife. So yeah, it's been a really fun learning process. It seems to be going well.
So how long is that knife? I didn't see it on your website.
It is 12 inches long overall.
Okay. And then what steel is that going to be? Also A2?
Right now, the production prototypes are A2, but I think even the early ones that go to customers will probably be AEBL.
Awesome. That'll be really nice to have a stainless in there for kitchen.
Yeah, 100%. So, I mean, the biggest thing for me right now is just working out, because I would like it to be kind of the same price as the Resolute, but you're talking about like a 12-inch long blade that potentially needs to be hand finished. That's like a pretty brutal amount of hand finishing. So I'm trying to work out like what I can do to minimize the hand finishing. So I'm looking into like ceramic brushes for finishing in the machine. I'm looking into longer vibratory tumbling, maybe multiple steps of vibratory tumbling, and then following that up with like hand finishing just to get that last 10%,
Right. Yeah, I heard you talking about one of those Zebek brushes on the last or two XYZs ago.
Yeah. And I want to try them out, but like, God, they're expensive. Like
Yeah.
for a half-inch brush with the sleeve, it's like $500.
Yeah. They
just for one,
really are. They make some cool stuff. Like I've wanted to use their stuff a bunch, but yeah, it's always like, I'm not going to spend $500 on this might work.
Yeah. And that's been kind of that's one of those things that I struggle with a bit, is like sometimes I shy away from that so much that when I do finally pull the trigger, I'm like, oh my God, why didn't I just fucking do this? It works, and then other times, so recently I bought an oscillating finishing machine, like it's a mold polishing machine.
Okay. Yeah.
So that I could try doing I use mold polishing stones to finish all my knives. And this thing's supposed to like move the mold polishing stones for you. And it sucks. It was expensive, and it works, but it's probably 2 to 3 times as slow as me just doing it by hand.
Right. Yeah. Yeah. Actually, we use Zebek's mold polishing stones at work. So that's kind of where I knew the name from. And I looked at their brushes quite a bit because they've also got like an automatic brush extending fixture that you can use with those too.
Right.
Where like you measure how much it loses every part or whatever, and then it just goes over and touches off on this fixture, and it'll actually move that collar up for you automatically.
Right. Which seems like, I don't know, I guess for some applications where you're like hanging off the edge of a part, it's going to be necessary. The other alternative for that, for me, because I'm going to be keeping the entire diameter of the brush within the part for the full finishing cycle, would just be like a spring-loaded engraving holder, using that to hold the brush.
Oh, okay. That makes sense.
Yeah. And they're like, $200 rather than like, I don't even have a price on that automatic adjustment system, but I'm sure it's not cheap.
Yeah. All I can think is find out whoever your local Zebek distributor is and be like, hey, you come in and bring a brush, and if it works, I'll buy one from you.
Yeah. And, maybe I should tell them that. I mean, I just, I said this on the podcast. I find the old school, like, distributor model for tools very, like, stressful and stupid.
I'm not a big fan either. Yeah. But when it comes to something that it's like, well, this might work, you're going to have to come prove it. Because, like $500, that's when it's like, well, is it going to be worth it or not? Or does it add to that pile of this is garbage?
Yeah, exactly. My expensive tools pile. Yeah, so we'll see.
All right.
That's the new hotness that's coming through at the moment is all kitchen knives.
Awesome. And where's the name come from?
So a triumvir means 1/3 of the ruling party, or like ancient Roman times, the triumvirate was like the thing that would, be your government.
Okay.
And that kind of blade shape is a Japanese origin, and it's called a santoku, which means the three virtues.
Oh, okay.
So it was just trying to tap into that, the idea of the three-sided nature of that shape of knife. It's for chopping, slicing, and veggie prep and stuff. So yeah, it's not necessarily a perfect name, but you know what, naming shit is hard.
Yeah,
you have to come up with something original.
No, I'm looking forward to seeing how it all goes because I love the look of it. The handle angles are great looking, so I'm really looking forward to seeing how it all comes together.
Thanks. Yeah, I'm. That was one of those things that just kind of happened as I was hand making the first prototype. Like originally it was supposed to be much more rounded, and the very first prototype has a much more rounded handle, and it just looks boring as fuck. It's not. Doesn't look different in any way. The angular kind of like stealth bomber. Like when I look at that, I see like an F-117 stealth fighter.
Oh, totally.
That's what I see, and I love that look. And it's faceted enough that like you don't even notice it when you're holding onto it. It's not like you've got like sharp angles sticking into your hand or anything. So yeah, I'm super happy with how it ended up turning out.
So briefly, totally off topic, but you mentioned the F-117, and I don't know if you've ever seen, I've mentioned him a few times on the channel, but Nicholas Means has all these talks that he does at developer conferences, and one of them is the history of Lockheed Martin's Skunkworks, and he goes through a few of their planes.
Yeah, I think I might have seen that talk, and it's a really good one.
Yeah, well, and my favorite whole thing of that is that the F-117 was designed, and they were like, this will never fly. Like it's I think they said it's unstable in every single axis. So they had to use a hacked F-16 flight computer because the F-16 is unstable in one flight axis. And so they were like, well, we can hack that software so that it works on all the axes. But apparently it was just incredibly unstable for the first few prototypes because they were trying to, like, the computer is actively fighting a plane that doesn't want to be in the air.
Yeah. Yeah, it's actively anti-crashing.
Right.
100% of the time.
Exactly.
Yeah.
So
yeah, my favorite bit of the development was like when they first were testing the radar cross-section of that plane. And they were like, we don't think the equipment's working. Like we can't see anything. And then a bird went and landed on the nose of the model, and the radar cross-section suddenly like tripled. And they're like, oh shit, okay, it's working.
Yeah. Exactly.
We just can't see the plane. And they ended up having to so the plane's mounted, I think they mount them upside down for some reason when they're testing them. And then it's mounted on this like pole, and they had to design like a stealth pole.
Yeah. It was like a $500,000 pole.
Yeah.
So they could pretend to see this plane that they couldn't see.
Yeah, exactly. Shit like that's just super cool. Yeah, I love stuff like that.
I'll link the talk in the show notes for anybody who hasn't seen it, because I've mentioned him a few times. He's got a bunch of talks that I recommend to everybody because he's such a nerd like about everything that I love it. Like he dives into the absolute nitty gritty. Like he's got one on why 3 Mile Island failed. He's got one on the DC-10 crash and how they saved half the people on board of this DC-10 that lost all hydraulic control. Yeah, it just he's like so good about really diving in and finding out the real story, and the one about Lockheed was just equally as fantastic. So
yeah. Well, and I love that the Skunkworks became such like an iconic name. Like if you say like Skunkworks to an airplane nerd or an engineering nerd, they're like, fuck yeah, But it like literally came because the place smelled like shit.
Yeah, exactly. They were next to a smelly plastics factory in a circus tent. Like it's like such an insane story that if you told it to anybody, they would not believe that it was a real thing.
Yeah, 100%. Yeah, very cool, man. We could nerd out about all that stuff all day.
Yeah. So anyway, I'll wrap up the episode. The last question I ask every single guest is, what did you research this week? What's been in your Google browser? It doesn't need to be machining related. It's just always cool to see what like-minded people are Googling.
Basalt fiber fabrics.
Okay.
So it turns out that there's like in between carbon fiber and fiberglass, there is a material that is like in the middle in terms of properties. And it's basalt fiber, like literally made from like volcanic rock. And shit looks awesome. I want to make some handle scales out of that.
Oh, okay. So, what properties are you looking for there?
For handle scales, I mean, it's literally going to be like, it looks cool.
Okay.
It has like an awesome like metallic bronze kind of color.
Oh, cool.
In the fiber. But in terms of like actual engineering properties, it's like very fire resistant, better modulus than S-glass, but like not quite as good as carbon fiber, but for like the same cost as S-glass fabric. Yeah, it's just super cool stuff.
Very cool. Well, Aaron, wrapping up the episode real quick. I've got a Patreon thank you for Nick Santiago. Thanks for joining the Patreon. Thank you, Aaron, for coming on and taking the time. And we will see you all next week.
Yeah, no worries, man. Thank you for having me.